welcome. In this tutorial video, I will demonstrate how you can create and customize summary statistics tables in KIWI Explorer. I will illustrate how you can select among the 5 different styles of tables, how you can select the variables and the statistics that are reported in these tables. And I will also illustrate the use of more advanced options such as stratifications and formatting. I will now switch to the application. I have opened KIWI Explorer and the Profile Manager for a unique analysis dataset called subset_demo.csv. This is the same population PK dataset that we have used in previous tutorials. I have run multiple profiles for these datasets, and I will use this profile to illustrate the different designs and options available in KIWI Explorer. I will start with the global profile. The global profile is the non-editable profile that is always available to you, and all the settings are defined or set to their default value. When you click on the profile or when you execute the global profile, you generate a single table which shows statistics for continuous variables and counts for categorical variables. The statistics are provided as an overall set of statistics. So there's no stratification of the numbers. And the tables also provide a footnote with the full definition of some abbreviation used in the table. So the list of variables included in this table is defined by the variable definition panel, and for the global profile, the covariables tables is set to all covariables. So if you're using the global profile, or if you're using a custom profile for which the covariables table is set this way, with the all covariables set in under the variable column, KIWI will interrogate the database and extract the list of continuous and categorical variables from the definitions that were set in the Configure Variable Categorization menu. The functionality of this panel was described in a separate tutorial, which I invite you to watch. Briefly, this table shows the list of the variables included in the datasets that were open. So in my case, only one dataset was open, and I see only one column. The variable listed as CO are the continuous variables. The variables listed as CA are considered categorical variables. So in this case, I had several CAs and COs, CO variables in this table. So this selection was reflected in the design of the table. You can control the list of variables that are included in the table beyond the categorization set in the Configure Variable Categorization by providing a custom list of variables in this covariables panel here. So this is what was done in the first custom profile, in which case I used a custom list of variables: age, creatinine clearance, body weight, and gender. These variables were set in the variable definitions panel. I have only 3 variables here. 3 are defined as continuous, and the last one, SXF, was defined as non-continuous, so categorical. I want to point out some additional functionalities of the covariable panel. You can provide labels, or custom labels, like for weight. I'm defining body weight kg. These custom labels would be used in the table, and they would override any variables and units that would have been defined in the configuration variable labels and units. This is another panel for which the functionalities have been defined in a separate tutorial. I also invite you to watch that tutorial to learn more about the functionality and how you can define custom labels or units, add variables in this library. Going back to this, how these covariables interact with this library of labels and how this is reflected in the table, you can see that for age, the content of the label column is set to default. In this case, KIWI will interrogate this library of labels and find maybe a label and unit, and in this case that would be reflected in the table. If the variable selected doesn't have a label and unit in this table, the summary statistics table would show the name of the variable instead of a label and unit. Another piece of customization that is specific to tables is the last column of this covariables panel. You can define the number of significant digits that would be used to report the statistics. So for age, in the profile we've used 3 significant digits, so we're getting at least 3 significant digits. If the numbers are actually whole numbers, like in this case would be 50.0, R, which is the environment that we use to create these tables, R will strip the last significant digits. But for creatinine clearance, we're using also 3 significant digits, and we get those 3 significant digits pretty much on all statistics. I use a higher number of significant digits for weight, and you can see that for weight I have 4 significant digits. One thing that I want to mention also is, as soon as you're defining a custom profile for summary statistics, you need to think about the data subset that you're using to generate the statistics. The default behavior of KIWI Explorer is to use the entire content of your data set, so all the records that provide information about age, all the records that provide information about CRCL. So typically when you want to create a summary statistics for subject characteristics, you want a subset to the first record per subject or the last record per subject, or at least one record per subject, to not bias the distribution of the statistics by an unbalanced number of records per subject. So for that you need to go to the data subset panel, and you can use different fields. The functionality of data subset is described in a separate video where you could learn more about all those 4 fields. For the purpose of this tutorial, I would just mention that I've selected this option for the keep field. I set that field to first record per subject, and the result is that I'm using 160 records instead of the 2,318 records that were used in the global profile. That gives me also the opportunity to mention that something that KIWI Explorer does automatically. KIWI Explorer, the summary statistics table, will automatically report the number of records and the number of subjects if those two values are different. So the capital N is the number of records used for the statistics. The lowercase n is the number of subjects that provided those records. So obviously what that means is that KIWI Explorer needs to know what is the variable that uniquely identify your subject. This is something that is controlled through the default variables panel, and the subject identifier variable. In this case it was set to default, which means that KIWI tries to find an ID variable, so literally ID, in your data set, and if it finds it, it can perform this automatic detection. If it does not find it, the plot will not be the tables will not be created, and you would need to edit your profile and provide the variables that uniquely identify your subjects. So these two profiles, the global profile and the first custom profile, illustrate the use of the default design of summary statistics tables, where the variables and the statistics are shown in rows. You can mutate or transform that table, how the statistics are reported, by selecting a different design. There is an alternative design where statistics are shown in column and variables are shown in rows. This is the second profile. And to obtain this alternative design, you need to go to the basic settings profile and select the design, or set the design to variables in rows and statistics in columns. This design only report statistics for continuous variables. So even if you set or select a continuous, a categorical variable in your field of in the covariables panels, these variables will be ignored. So in this case, success is not reported here. There's an alternative design, kind of the transposed version of this design, in which the statistics are shown by rows and the variables are shown by column. This is another possible selection of the design field: variables in columns, statistics in rows. And again, this design will ignore any categorical variable that you provide. Coming back to the first design, I want to illustrate some functionality of stratification. This functionality was already introduced in a separate tutorial on data stratification for plots and tables. Just want to illustrate that quickly in this particular tutorial dedicated to the summary statistics tables. So you can provide or use different types of stratification. You can use stratification within tables, so you'll get not only statistics that are computed for the overall data, but you can compute those statistics for distinct value of your stratification variable. You can also break the data and show the statistics in different tables for specific value of another type of stratification. So the way that was done for this particular profile was to go to the stratification panel and go to the table by tab. It has a single field which allows the selection of one or more variables that will control how the data is broken into multiple tables. So in this case I had only one, and each table is specific to a value of this study variable. So study 1, study 2, study 3. To break the data or the statistics into multiple columns, you need to go to the stratification panel and include one or many stratification variables that you would select in the left column. The right column provide a text that would be shown on the left of the variable values. So in this case I did not put any text, and in this case I get only the value of the selected variable, so gtreat. And you can see that not every tables need to have the same values or the full list of values. So that's how you stratify the data. Stratification could be used for any of these design, 1, 2, or 3. The result would be a little bit different depending on the selected design. Not necessarily in terms of statistics, but how the table is designed, or the layout of the table would be a little bit different. Now I want to, before moving on to the next type of study design, I want to illustrate the use of some additional customization options. I've copied this fourth profile and created this fifth profile where I've implemented some additional customization. The first one is the control. I've requested the display of additional variables or additional statistics. The way you do that is by going to the summary statistics panel, and from this panel you can control what is displayed, the list of statistics that are displayed. For continuous variables, in this case I set all the possible statistics to true. If you select the where is that confidence interval, here the confidence interval is right there. So if you don't provide a value, the confidence interval is not shown. If you provide a value in the confidence interval, the associated percentiles are shown. So in this case I use the 80% confidence interval. This is delimited by the 10th and the 90th percentile of the data. So there's a lot of statistics that you can show: mean, median, standard deviation, standard error, coefficient of variation, statistic on the geometrical scale, min max, number of records, and so on. Statistics that you it's not necessarily statistics, but the way percentages are computed and reported for a categorical variable. You can define the calculation by row or by column. If you define the percentage by row, the sum of the percentage would be 100 within a row. If you define the calculation by column, which is the alternative option, the sum of the percentages will be 100 for within a column and not within a row. So that's how you can control the statistics. You can also request to show or not show statistics for the overall data, so something that would ignore the stratification within a table. So that's the extent of control you have on the statistics. The other customization that I've applied in this particular profile is the use of data formatting or format collection. The way you can define data format which transform numerical value into text-based information. So in this case, my treatment was 1, 2, 3, 4, 5, 6, 7, 8 in the previous profile, and it's transformed into some more meaningful dose information. The same for my study. How this is controlled was described in a separate tutorial video on data formatting. I will refer you to this separate tutorial to learn more about how you define those formats. How you apply the format is by selecting a format collection in this field, the first field of the basic setting panel. So moving on to the next type of style of tables available in KIWI Explore, you can create this style of table where typically it's the value of the dependent variable, so your concentration, your drug concentration, or your endpoint. Is the value of this endpoint is reported for each subject at each value of typically nominal time. And in addition to those individual values, the table reports some statistics. So it's a combination of the summary statistics design that we've described for the first design and the ability to show the individual value. This is a type of design that you frequently see in non-compartment analysis. That's why we refer to that as the Nca Profile. So the way you define this profile, this type of profile, is by going to first of all the basic settings needs to be set to, or the design needs to be set to individual values in rows and statistics in rows. You also need to be mindful about the data subset. In this case, I didn't want to show all the data, but I subset it to records that match this expression. The study equal 1, so that would be all the data from my first study, and the records that would also have the SAMP variable set to 1. The SAMP variable was a flag variables which could take two values, 0 or 1. 1 would indicate the records associated with measurements of the endpoint, and I kept all the records within that subset. So that allows the table to show all the records for within a subject. You also need to define two additional things. You need to define the variable that you want to represent in the table as a covariable. So in my case, I selected the dependent variable dv as a continuous variable. You don't really need to put any label because it's not really reflected anywhere. But you need to define the number of significant digits that are used for the actual values and the statistics. So this is defining the variables that are reported in the table. You also need to define the variable that will stratify that data, and you need to go to stratification, you can use a table by that would break the data into multiple tables, but you need to provide a variable for the within table stratification. So in that case, I use the TSLD, so my time since last dose. There is a lot of special behavior with this table. First off, the table reflects the missing information. So if you have a record that was either not there for subject 1006 at time 0.5, if the record was not there, the table will report missing. Similarly, if there was a record at this particular time, but the value was NA, which is the way our record missing information, the table will also report missing. The number of missing records per time is reported automatically in the table. The data that is below the limit of quantification, which is a functionality available in the BLQ handling panel. This functionality was described in detail in another tutorial, but in case you would use method that would exclude or transform BLQ records, this table would report the records that are identified as BLQ using lower than LLOQ content, and the statistics would either exclude those records or use the transform value, which could be 0, half the LLOQ, or the LLOQ. Again, that functionality is extensively described in this separate tutorial. So I'm going to close these panels before switching to the last design of tables available in KIWI Explore. The four designs that we have described so far are specifically tailored for continuous variables. The first one is also allowing categorical variables to be reported. The last design, design number 5, is meant to report contingency table or frequency tables. It's basically reporting the count of records that are associated with a combination of two categorical variables. So I'm going to quickly switch to the this profile and show the list of, just going to see that in the view mode, the list of variables that were set in the covariables panel. I set three variables that all are categorical. As a result, I got all the possible combinations of those three variables. So when you have 3, you get 3 tables. And here I've applied some formatting, so my gender and my treatment and my study are formatted. The tables show the frequency of records that are associated with the different combinations of, in this case, G-treat and SEXF. Below the table, the result of a chi-square test is provided. So there are different statistics reported here. You can control various elements of this table. You can control or request the display of additional statistics. So in this case, I've got the same table for using non-formatted variable, but I also get not only the frequency, but the chi-square contribution of each cell to the overall chi-square statistics. You can report the percentage. So what was what was the percentage associated with this count, considering the overall count, which was 160. You can get this the percentage by row and the percentage by column. This is controlled by the contingency panel. In this case, I set all my statistics to true, and you can set those statistics to false if you don't need them. Like that's what I've done in the design or the profile number 7. Sometimes you have if your variables include many categories, both on the y dimension and x dimension, sometimes the p-value cannot be the p-value of the chi-square test cannot be computed by the default asymptotic method, and you may need to switch the field or use the field of the second panel here for the calculation of statistics. You may have to switch that field to true, in which case the p-value would be computed by Monte Carlo simulations, and you can set the number of replicates used to calculate that p-value in the second field. So this is an overview of the different functionality available in KIWI Explorer to create summary statistics tables, either for continuous or categorical variables. Thank you very much.